Welcome back to the deep dive. This week, we're looking at a period that, well, it felt less like a wave of innovation and more like a tsunami.
That's a good way to put it. An absolute flood of updates.
We're focused purely on updates released over just two hyper-productive days, November 20th and 21st, 2025.
It was an intense 48 hours. For our technical audience, you can't just browse the headlines with nearly 80 announcements. It's just too much.
No, you really can't.
You have to be analytical, you have to categorize these changes, and really, you need to pull out the critical facts that are going to impact your deployments, your security, and, the bottom line.
Absolutely. So the goal here is pretty simple. We're giving you the most efficient, technically rigorous shortcut possible. This deep dive is really structured for the engineer, the solutions architect, or the data scientist who needs to know what just changed.
And more importantly, what they need to act on right now. When you pull all this material together, two big strategic trends really emerge. First, there's this heavy focus on accelerating developer and data science workflows.
Okay.
A lot of that is through AI agents and consolidating these complex analytics tools into unified serverless environments.
And the second trend?
The second, and I think this is maybe more fundamental, is the foundational hardening of security. We're seeing production-ready, almost mandatory steps toward post-quantum cryptography.
Wow, okay.
And some really unprecedented governance enforcement.
That sounds like a technical mandate. So let's get into the structure. We are going to begin with what should always come first.
Security.
Future-proofing security, compliance, and governance. From there, we'll move into the massive overhaul in data analytics, particularly around Spark and Iceberg.
Yeah, there's a lot to unpack there.
Then we'll cover core compute and containers, finish with databases, and we'll wrap up with networking and operational observability, including this whole new wave of AI-powered troubleshooting.
So for segment one, we absolutely must start with the longest-term security threat out there.
Quantum computing.
Quantum computing. Specifically, the industry is facing what's called the harvest now, decrypt later problem.
Right. And for our listeners who might not live and breathe cryptography, harvest now, decrypt later is basically this idea that highly sensitive, long-lived data, so think financial records, medical data, intellectual property, it's being collected and encrypted today with our current methods, but with the knowledge that future quantum computers will they'll break that encryption easily.
Exactly. The data is harvested now to be decrypted later when the tech catches up.
A very scary thought.
It is. And the immediate defense is the expansion of post-quantum cryptography, or PQC. We saw this pop up in two really mission-critical areas.
Okay, what first?
The first is for those highly sensitive API transmissions. AWS Payments Cryptography, that's Update 3, now supports hybrid post-quantum TLS to secure API calls.
And they're specifically using ML-Chem, right? That's the core algorithm selected by NIST, the National Institute of Standards and Technology.
That's the one. Module lattice-based key encapsulation mechanism, if you want the full name.
I think I'm good with ML-Chem.
Yeah, me too. But the crucial point here is that they adopted a hybrid approach. It's not a complete switch to PQC.
So what does hybrid mean in this context?
It means they combine a classical key exchange, something like ECDH that we use today, with ML-Chem. This gives you a safety net.
So if ML-Chem has some, unforeseen vulnerability down the road, you're not completely exposed?
Precisely. Or if the classic systems are misconfigured, you still have the protection of the established, battle-tested classic encryption. It's like a confidence-building bridge to the quantum era.
And that protection is now being pushed all the way to the network edge, which is a huge deal.
It's massive. Application load balancers, your ALBs, and network load balancers, NLBs, also launch support for these PQ-TLS security policies.
So that's update 50.
Right. And this means that the initial connection handshake for any application sitting behind these load balancers can now be quantum safe.
That's a very high-level defensive layer, but I assume there's an action item here for our listeners.
Oh, yeah, and here's where the operational checklist comes in. This is not a default setting. I want to be really clear about that.
Okay, so it opt-in.
It's opt-in. You must explicitly update your existing ALB HTTPS listeners or your NLB TLS listeners to use the new PQ-TLS security policy.
Okay.
If you manage hundreds of these, that requires immediate inventory and, deployment action.
So the change forces the security team to actively engage. Once they've deployed it, how do they actually validate that it's working?
The ability to monitor this is built right into the service logs. which is great. You can check the usage of these quantum-safe exchanges directly using either the ALB connection logs or the NLB access logs.
And what are you looking for in those logs?
You're looking for the specific cipher suite negotiation. That confirms that the hybrid PQC exchange happened successfully, and that's your proof that your quantum resistance is active against that harvest now threat.
Got it. Okay, so moving from these future threats to more current internal compliance needs, we have a massive foundational security shift with Update 23.
Yes, the launch of VPC encryption controls. For any organization driven by compliance, this simplifies an enormous burden.
Why is that? What was the burden before?
Well, compliance frameworks like PCI DSS, HIPAA, FedRAMP, they often require explicit proof that your data is encrypted in transit, even inside the so-called trusted boundary of your own VPC.
Right, which used to be a real pain to prove.
It was. Achieving that end-to-end guarantee meant tracking a bunch of different application layer settings and really knowing your underlying instance types. VPC encryption controls just centralizes that enforcement.
So what exactly does it enforce when you turn it on?
When you activate it, it automatically and transparently turns on hardware-based AES 256 encryption on traffic between specific core VPC resources.
Okay, like what?
We're talking about traffic between Fargate tasks, NLBs, and ALBs. It just removes all the ambiguity.
I'm going to challenge that a little bit because AWS already provides transparent hardware-based AES 256 encryption between modern EC2 Nitro instances, and they encrypt all interregion traffic automatically. So how is this new VPC control different?
That's a great point, and it's a common question. The existing Nitro encryption covers that instance-to-instance traffic and interregion traffic, you're right.
So what's new?
The new VPC encryption controls extend that same hardware-guaranteed encryption to the communication between the managed services within the VPC boundary, things that might not be running on a standard Nitro instance.
So like traffic flowing directly into a load balancer from a source that isn't another Nitro instance.
Or between serverless Fargate tasks. It closes the remaining gaps in that transparent internal traffic encryption. It makes the guarantee complete.
And there's an immediate tie-in for how you provision infrastructure with EC2 Fleet, right? Update 45?
Yes. EC2 Fleet now supports a new attribute for its attribute-based instance type selection, or ABIs. It's called Require Encryption in Transit.
Okay, and how would you use that?
So if you're using VPC encryption controls in a strict enforcement mode, you can use this new attribute when you create your EC2 fleet. This guarantees that only instance types that are capable of supporting that hardware-level encryption are ever launched.
So it complements the VPC controls by locking down the requirement at the provisioning layer itself.
Exactly. It prevents a developer from accidentally launching an older, non-compliant instance type and breaking your compliance posture.
Very clever. Okay, let's shift focus to container supply chain security. The operational uplift for managed container image signing in ECR, Amazon's container registry, seems like a huge step left for security.
It really is. I mean, the biggest hurdle to adopting image signing, which is what verifies the provenance of your container images.
Where it came from, who built it.
Exactly. The biggest hurdle was the management overhead. You had key generation, secure storage, rotation, certificate lifecycle management. It was a nightmare.
So what did ECR do?
They solved this by leveraging another service, AWS Signer. Now, you just define a signing rule that's tied to an AWS Signer profile, and ECR automatically signs your images upon push.
So a developer pushes an image, and ECR just handles the entire crypto operation using a pre-configured audited key.
Precisely. And because the system uses the identity of the pusher, the IAM user, or role that did the push, the entire operation is auditable via CloudTrail.
So if an image turns out to be malicious, you have this unbreakable chain of custody.
You've got the image, the signature, the key, and the identity that performed the action. It's automated, high-assurance trust verification, and it removes the main reason developers previously just skipped this step.
Because it was too hard.
It was too hard.
Okay, so moving from the registry into the cluster itself, Kubernetes secrets management got a lot easier.
It did. Amazon EKS add-ons now support the AWS Secret Store CSI driver provider. This is Update 25.
This sounds like a classic manage the add-on lifecycle for me feature.
That's exactly what it is. For Kubernetes users, managing secrets usually involves installing the CSI driver, the container storage interface driver, configuring all the permissions, handling updates. It's a lot of work.
So what does the EKS add-on do?
It automates the entire installation and lifecycle management. So it handles retrieving secrets from Secrets Manager and parameters from Parameter Store, and then securely mounting them as files or environment variables on your Kubernetes cluster.
So it just simplifies the security configuration immensely.
It does, and it ensures secrets are handled by AWS services designed specifically for that purpose, not, checked into Git.
Definitely a good thing. And finally, a necessary standardization update for large-scale enterprise networking.
Yes, AWS Security Token Service, or STS, now supports IPv6 addresses.
Via new dual-stack endpoints, and that includes private access through AWS Private Link. This is Update 54.
Yeah, for massive organizations, especially governments or large service providers, IPv4 address exhaustion is a real problem, and network standardization requirements are often mandatory.
And STS is fundamental to everything you do in AWS.
It is. It handles all your temporary credential generation. So if you are mandated to run your core traffic over IPv6, having STS accessible over dual stack and securely via private link, it just removes a critical networking hurdle and a compliance blocker.
All right, let's talk governance, because this is where the philosophy of control seems to be changing really fast. First, this incredible modularization of AWS Control Tower.
This is a huge acknowledgement of the complexity in mature enterprise environments. Control Tower is fantastic for greenfield deployments, right?
Yeah.
New AWS accounts.
But not so much for existing complex ones.
Exactly. Organizations with existing complex AWS organizations often found the mandatory prescriptive structure just too constraining. Now, customers can get direct access to the control catalog that's over 750 managed controls without having to deploy the full mandatory control tower structure.
Yeah. So they can just pick and choose the specific preventative or detective controls they need, rather than having the entire organizational scaffolding imposed on them.
That's it. It offers flexibility without sacrificing the benefit of AWS managed governance controls, which, include automated deployment and continuous auditing.
So let's mature organizations start adopting these best practices incrementally.
Yes, applying them where they need them most without sacrificing their existing organizational autonomy. It's a really smart move.
And the breadth of those controls is growing fast. Update 26 detail support for 279 additional managed config rules and 7 new compliance frameworks.
Yeah, things like the Australian ACSC Essential 8 and specific CIS AWS benchmark versions.
But beyond just the sheer number of rules, what's the technical improvement here?
It's the enhanced control relationship mapping. Control Tower now explicitly identifies complementary or mutually exclusive controls.
What does that mean in practice?
It helps you confirm, for example, that a specific config rule for detection is properly paired with a corresponding service control policy, or SCP, for prevention in your organization.
So it makes sure you have comprehensive coverage and you don't have conflicting rules.
Right, it eliminates potential conflicts and gaps.
Okay, now let's pivot to what I think is maybe the most disruptive governance update of the bunch. Proactive compliance enforcement using AWS organizations' tag policies.
Oh, this is a paradigm shift.
It fundamentally shifts the security feedback loop into the developer's hands right at the build stage.
It's a complete shift left.
Yeah.
Traditionally, resource tagging, which is essential for billing, for chargeback, security classification, it was all handled with detective controls.
So the infrastructure was launched, and 3 days later, an auditor or a config rule would flag that the required owner or environment tag was missing.
And you had compliance drift.
Yeah.
And the remediation effort was just painful.
Very painful.
Now, organizations' tag policies support something called reporting for required tags. And this validation check integrates directly into the developer's infrastructure as code tooling.
So CloudFormation, Terraform, Pulumi.
All of them. It proactively ensures that mandatory tag keys are present before the resource is ever provisioned.
So if I launch a CloudFormation stack and it doesn't include the mandatory owner tag that's defined in my tag policy, the stack just fails immediately.
Precisely. You activate the relevant validator hook, like the AWS tag policies, tagging compliance validator in your CloudFormation execution roles, and the enforcement happens proactively right at the deployment stage.
That's a huge win.
It is, because it guarantees consistency, it eliminates that whole remediation cycle, and it pushes compliance enforcement to the IAC layer where it belongs. It moves compliance from auditing failures to actively preventing them.
A fantastic operational point. One last update in governance before we move on. License Manager introduced automated license asset groups.
Yeah, for large organizations dealing with complex vendor agreements, this is a necessary chore simplification.
So what does it do?
It basically streamlines the tracking of license expiry and usage across all your different accounts and regions. If you're managing hundreds of Oracle or SQL Server licenses, having a centralized view that automates the inventory and reconciliation process just Well, it significantly simplifies your audit responses and your renewal decisions.
All right, if segment 1 was all about security, segment 2 is about sheer speed and acceleration. We saw an explosion of updates centered on modernizing the Spark ecosystem and achieving a true convergence for ML workflows.
Absolutely. And the headline update here is foundational. EMR Serverless now supports Apache Spark 4.0.1 in preview.
That's update 1. So this is the next major version, and it sounds like it has some immediate benefits for building modern data pipelines.
It does. Let's talk about the immediate technical gains for engineers moving to 4.0.1.
Okay.
First, better pipeline development accessibility. Spark 4.0.1 supports standard ANSI SQL compliance and introduces built-in variant data types.
Okay, variant data types. Why is that a huge deal?
Because it natively supports semi-structured data, like JSON, directly within the SQL layer. So you don't need to write complex user-defined functions or UDFs or do a ton of pre-processing anymore.
So it makes the ETL process more accessible to data analysts who might be SQL experts but not necessarily Python or Scala experts.
Exactly. It immediately simplifies ETL for any modern data source that relies on nested JSON or schema evolution.
That makes a lot of sense.
And secondly, governance is strengthened. It has built-in compliance for the Apache Iceberg v3 table format, which provides transaction guarantees and comprehensive audit trails. That's crucial for regulated industries.
And that leads us directly to Update 10. Amazon EMR 7.16 is now generally available, and it features native support for Apache Iceberg v3.
Right, alongside the latest Spark 3.5.6 and Trino 476. So we really need to dig into the technical benefits of adopting Iceberg v3.
Let's do it. You said there are 3 core benefits.
Yeah, I'd categorize them as operational, cost-related, and regulatory.
Okay, let's start with the operational and cost benefits. How does v3 actually save you money?
Through smarter deletion management. In older versions of these open table formats, if you wanted to delete a single row, you often had to rewrite the entire underlying data file. It was incredibly inefficient.
A huge amount of I/O.
A huge amount. Iceberg v3 implements what are called deletion markers. So it just marks specific rows for deletion without requiring that full file rewrite.
So it speeds up pipelines with frequent updates or deletions?
It does. And critically, it cuts your storage and compute costs by avoiding all that unnecessary I/O on S3.
And for governance, you mentioned robust change data capture, or CDC.
Yes. v3 provides enhanced governance through automatic tracking of row creation and modification history. This makes robust CDC much easier to implement right out of the box.
So for compliance teams, that means having reliable automated audit trails.
Exactly. Detailing when data was changed and by whom. And finally, v3 offers enhanced data security with table-level encryption. So it's another layer of defense for PII and sensitive data, and it integrates seamlessly with AWS Lite Formation for unified governance.
Got it. Okay, now let's look at Athena. The focus there seems to be heavily on automation and cost control for reserve capacity.
It is. Update 37 details an auto-scaling solution for capacity reservations.
And managing reserve capacity or deep use data processing units in Athena was historically a real challenge, wasn't it?
It was a huge balancing act. You either over-provisioned to handle your peak loads, which led to waste, or you under-provisioned, and then you had queuing during busy periods. This new solution eliminates that manual work.
So how is the automation implemented?
It uses a serverless architecture. It combines AWS step functions and CloudWatch utilization metrics. You define thresholds based on your typical DPU consumption or maybe your queue depth, and the step function workflow just dynamically adjusts the reserve DPUs up or down.
So for data teams with predictable bursts, like end-of-quarter reporting,
it's perfect for them. It ensures your reserve capacity aligns precisely with the actual workload demand. You get fast query results without any manual overhead.
That dynamic scaling addresses the overall capacity, but Update 15 introduced some really granular controls.
Yes, the ability to configure DPU settings at the workgroup or even at the query level.
Why is that so important?
It's essential for mixed workload environments where cost visibility is paramount. Imagine you have a $500,000 query that needs to run instantly, and then you have a $5 query for ad hoc exploration.
Right. Previously, they just compete for the same resources.
They'd hit the same DPU pool randomly. Now you can set explicit DPU values per query, guaranteeing that your critical, high-priority queries get the resources they need, while the small, cost-sensitive queries don't over-provision or block that critical work.
And the key to making all of this work is visibility.
Precisely. The Athena console and API now return per-query DPU usage metrics. Before, you only saw aggregated usage. Now you have the fine-grained data you need to do accurate chargeback and cost determination for individual teams or specific analytical pipelines.
It's the level of visibility that technical teams have been demanding for a while.
It really is.
So the overwhelming architectural theme in the data space seems to be consolidation. And SageMaker Unified Studio is rapidly becoming the center of gravity for this whole analytics and ML workflow.
It absolutely is. We saw Amazon Athena for Apache Spark integrated directly into SageMaker notebooks. That's update 2.
So this is the realization of the serverless data scientist workbench.
That's a great way to put it. Data engineers, analysts, data scientists, they can now query data using Spark 3.5.6, run Python code for pre-processing, train models, and visualize results, all in one serverless workspace with second-level billing.
And it all just works together.
Yeah, the integration uses Spark Connect for secure interactive communication, and they've even included real-time monitoring via the Spark UI directly within the SageMaker environment.
And that unification is being dramatically accelerated by AI.
It is. The new notebook experience features a built-in AI agent, the SageMaker data agent.
So this is a major workflow disruption tool.
I think so. The data agent operates based on natural language prompts. It generates detailed execution plans and the necessary SQL or Python code for complex transformations, statistical analysis, or data cleaning.
And it's context-aware.
Yes, since it maintains awareness of the notebook context, what data sources are connected, the schema, what libraries are loaded, it dramatically reduces the need for boilerplate coding and complex syntax memorization. It's going to accelerate development by an order of magnitude.
I can see the immediate benefit for speed. And onboarding seems to be almost instant now, with one-click onboarding of existing data sets.
Yeah, the operational friction has just been minimized. The beauty of this feature is that if you have an existing data set managed in Glue or Lake Formation, you just click Get Started from the source console.
And SageMaker does the rest.
It handles the project setup, pre-configuring the notebook, the serverless compute, and all the permissions using your existing IAM roles. It cuts the time to first query from hours, spent configuring connectivity down to just minutes.
And this centralization also extends to these really long-running, resource-intensive jobs.
It does. SageMaker Unified Studio now supports long-running sessions up to 90 days using corporate identities via IAM Identity Center's Trusted Identity Propagation, or TPS.
So that solves a critical governance and operational problem.
It does. Data processing jobs on EMR or Glue can take many, many hours. If a user starts a job and their short-lived IAM credentials expire, that job previously risked failure or required these cumbersome renewal mechanisms.
But TP solves that.
TP ensures the job maintains continuous authorization by securely propagating the corporate identity from IAM Identity Center.
So even if the user logs off, the background process can persist for up to 90 days, and the security team retains full audit traceability back to the original corporate identity.
Exactly. It's operational continuity with enterprise-grade governance. And we also saw EMR and EKS integration in Unified Studio, which brings the scaling and cost optimization of EMR and EKS into this new seamless environment.
Okay, let's talk about data plumbing and AWS Glue. For DynamoDB users, Update 39 is a massive quality-of-life improvement.
It is a new DynamoDB connector with native Apache Spark data frame support.
And why is that such a big deal?
It's a major technical convenience. Previously, Glue's interaction with DynamoDB required you to use these Glue-specific dynamic frames,
which were functional but not standard.
Right. They complicated code reuse and integration with standard open-source Spark libraries. By supporting native Spark data frames, engineers can use the full spectrum of Spark operations, which simplifies their code and reduces migration friction.
Makes sense. Shifting to zero ETL, this technology seems to be becoming enterprise-ready. First, it now supports infrastructure as code.
Yes, via CloudFormation and the AWS CDK. And this is what makes zero ETL adoptable at scale. Data engineering teams rely on IAC to consistently deploy and manage their pipelines.
So being able to version control and deploy these zero ETL configurations is table stakes for enterprise adoption.
Absolutely. And second, Glue enhanced its zero ETL support for SAP entities, which is historically a tricky area.
What did they add?
They now support full snapshot data ingestion for SAP entities that lack native change data capture, or CDC. So you can still get that data into your pipeline, even if the source system isn't perfectly modern.
So it reduces exceptions and custom work.
Exactly. And they also added incremental loading for non-ODP entities using timestamps. It just reduces the custom engineering effort when you're integrating with complex SAP environments.
All right, moving from data to the compute layer, it feels like we're seeing container services being optimized for two very different audiences.
Yeah, you have the extreme scale HPC user on one end and the developer seeking maximum velocity on the other.
That dichotomy is really clear. So for the ultra-scale high-performance environments, EKS introduced the provision control plane.
Right. This is designed for environments where the control plane performance itself can actually become the bottleneck.
Walk us through that. At massive scale, what causes the Kubernetes control plane to bottleneck?
It typically happens during burst events. So think massive auto-scaling, high-frequency AI inference deployments, or large job submissions. The sheer volume of API calls against the Kube API server, etc., can just overwhelm the control plane.
And that leads to latency in pod scheduling and scaling.
Exactly. So the provision control plane addresses this by letting customers select specific capacity tiers for the control plane.
So instead of relying on the standard shared capacity, you're provisioning dedicated resources to ensure predictable, low-latency performance.
That's it. It guarantees consistent control plane behavior regardless of the cluster size, which is critical for customers running massive AI training jobs. It unlocks significantly higher scalability.
Okay, now let's go to the complete other end of the spectrum with ECS Express Mode, which seems purely focused on developer speed.
It is. ECS Express Mode is designed for rapid deployment of containerized web apps and APIs without diving deep into networking. It automatically provisions the whole underlying architecture.
The compute, the networking, security groups, and ALB.
All of it. But what makes it technically efficient beyond just the simplicity is the consolidation mechanism.
Okay, tell me about that.
It can efficiently consolidate up to 25 Express Mode services behind a single application load balancer. It uses intelligent rule-based routing to distinguish between them.
So it balances simplicity for the developer with resource efficiency for the ops team.
Precisely. And crucially, all the provisioned infrastructure remains fully accessible and modifiable. You start simple, but you don't hit a flexibility dead end.
And the AI focus continues in the container space with managed MCP servers for EKS and ECS.
Yes, MCP, or Model Context Protocol. This is critical infrastructure for the next generation of AI coding assistants.
So this is like giving my AI assistant a backstage pass to my cluster.
That's a perfect analogy. MCP provides a standardized interface for AI tools to request and receive real-time contextual knowledge about the cluster state. And by offering it as a fully managed server, AWS abstracts away all the complexity of installation and patching.
So AI coding assistants like Kiro or Cursor gain this deep operational context about the running cluster.
Exactly. The pod states, resource limits, network topology, which allows them to generate much more optimized code and perform more effective, context-aware debugging for the operator. The assistants become specific to your environment.
That's a huge leap. And for clients in highly regulated sectors.
For them, ECS managed instances are now available in AWS GovCloud US regions. This is about bringing that fully managed compute benefit, the automated scaling, task placement, regular patching to environments with the most stringent operational requirements.
Okay, let's talk about Lambda, specifically around Kafka. Update 56 provides a substantial cost optimization for provisioned mode Kafka ESMs.
Event source mappings, yeah. They're claiming cost reductions of up to 90% for low throughput workloads. That's a really impressive figure.
It is. How are they achieving that?
The savings come from two technical changes focused on increasing density and capacity sharing. First, the default density of event pollers per EPU, or event poller unit, has been increased significantly.
From 4 to 10 for low throughput cases.
Right, so that immediately increases utilization. But the sharing mechanism is the real key innovation.
Okay, what's that?
Customers can now group multiple Kafka ESMs within the same VPC using a new parameter called poller group name. And when you group them, these low-throughput streams share the underlying EPU capacity.
I see. So if I have 10 different microservices listening to 10 different Kafka topics, and each one only processes messages sporadically.
Instead of reserving capacity for 10 separate EPUs?
They can share the pooled capacity under that one poller group name.
Exactly. It dramatically improves EPU utilization and cuts your idle costs. It's a huge win for serverless cost efficiency.
Shifting to performance visibility for ML and AI, CloudWatch Container Insights got some critical updates.
It did. We now have support for sub-minute GPU metrics on EKS.
And this is a direct response to the nature of modern ML inference, right?
It is. Many inference jobs, like real-time API requests, they complete in less than 60 seconds. If your monitoring system only samples GPU usage every minute, you just miss critical performance data.
So you can't optimize or troubleshoot those short-duration workloads.
Right. Sub-minute frequency ensures you capture that granular resource consumption. And second, Container Insights now supports Neuron Ultra servers on EKS.
And Neuron Ultra servers are these massive multi-instance compute units for Trainium and Inferentia.
Exactly. Monitoring them requires aggregation. So CloudWatch now provides aggregate metrics specifically for the Ultra server IDs, which simplifies the view for ML engineers. Instead of looking at 16 separate instances, they see consolidated performance data for the entire logical server.
Nice. Okay, infrastructure management got streamlined with EC2 Image Builder, auto-versioning for recipes, and build versions.
This is a necessary piece of automation for CI/CD pipelines. Managing manual version numbers and image recipes is just tedious and error-prone.
So now you can use a wildcard.
Yeah, you use a wildcard pattern like X in the version number, and Image Builder automatically detects the latest compatible version and increments it on build. It lets your pipelines dynamically reference the latest stable image versions without manual updates.
And complementing the build process, Update 46 introduced flexible AMI distribution.
Yeah, this creates a new mechanism called distribution workflows. It lets you distribute an existing AMI to multiple regions and accounts, decoupling the distribution from the initial build and test pipeline.
And the key benefit is customization.
It is. You can now define custom steps within that distribution workflow. For example, you can include a wait for action checkpoint.
So you can pause the rollout for external validation?
Precisely. You can pause the pipeline after copying the AMI to a test region, wait for a manual sign-off or an external security scan before you proceed to production regions. It provides granular control and necessary gating for high-assurance environments.
All right, our next major area covers databases, focusing heavily on scale, operational insights, and governance across both Aurora and RDS.
And starting with scale, Amazon Aurora DSQL clusters now support up to 256 terabytes of storage volume.
That's double the previous limit.
It is. It doubles the 128 TB limit. And while Aurora is already designed for massive scale, removing this constraint just simplifies data management for those petabyte-scale application tiers.
From a developer workflow perspective, Update 66 seems like a huge convenience feature, an integrated query editor right in the AWS Management Console for Aurora DSQL.
Yeah, this feature drastically reduces friction for developers and admins. You no longer need to spend time configuring external clients, firewall rules, security groups, just to run an ad hoc query or validate a schema change.
So it accelerates the time to value, especially during troubleshooting.
Absolutely.
Yeah.
Secure, browser-based SQL access with syntax highlighting, auto-completion, it's a no-brainer.
Okay, now let's talk about cost visibility. This is a big one. Update 88 introduced statement-level cost estimates directly within Aurora DSQL query plans. For a DBA, how does this change the way they tune queries?
This is arguably the most powerful operational insight provided in this whole wave of updates for DBAs.
Why do you say that?
Because traditionally, tuning a complex query meant relying on CloudWatch metrics and general explain plans. They told you what the query was doing, but not how much it cost in near real time.
So now, when a DBA runs explain, analyze, verbose, that highly detailed query plan, what exactly do they see in terms of cost?
They see estimated DPU usage appended right to the plan output. And it's broken down by category: compute time, read ops, write ops, and multi-region write ops.
So you get this fine-grained statement-level visibility into which specific part of a complex join or aggregation is driving resource consumption.
Exactly. It allows for immediate tuning decisions aimed at reducing cost rather than waiting for aggregated metrics to show up hours later.
That real-time feedback loop between performance optimization and cost is, well, it's revolutionary for serverless database tuning.
It really is. It connects resource consumption directly to code execution. And to simplify the security for this, the new Aurora DSQL connectors for Python, Node.js, and JDBC simplify IAM authorization.
And how do they do that?
The connectors act as a transparent authentication layer. They handle the automatic generation of IAM tokens using the developer's valid AWS credentials.
So developers don't have to write custom token generation code.
And crucially, it removes the security risk associated with managing traditional long-lived database passwords. It forces adherence to IAM-based access, which is a huge security best practice.
Definitely. Moving to RDS governance, AWS Organizations now supports an upgrade rollout policy for Aurora and RDS. This sounds like a solution to a chronic enterprise operations problem.
It absolutely is.
Yeah.
Managing automatic minor version upgrades across hundreds of production database instances simultaneously introduces just a massive amount of risk.
So how does the new policy work?
It allows organizations to stagger upgrades using simple defined orders like first, second, last, and you apply them via account-level policies or resource tags.
So an admin can tag all their dev instances as first and production instances as last, guaranteeing the upgrade path is validated.
Correct. The policy guarantees that upgrades are validated in non-critical environments before they ever roll out to production, and you get AWS health notifications between the phases.
So if an issue is detected in the first phase,
The organization have the power to pause the progression entirely before it impacts any critical production systems. It's operational control injected right into that automated update process.
for SQL Server users, we saw two great updates. First, RDS for SQL Server Enterprise Edition now supports Resource Governor.
Yeah, Resource Governor is a classic DBA tool. Bringing it to RDS for SQL Server Enterprise provides really granular performance optimization. It lets DBAs manage how different workloads, like a high-volume transactional workload versus a complex analytical report, consume CPU, memory, and I/O.
Which is essential for guaranteeing performance SLAs in shared or multi-tenant environments.
Exactly. And high availability just became accessible for a broader audience. RDS for SQL Server now supports multi-AZ for the web edition.
So previously, if you wanted HA for SQL Server Web Edition, you had to migrate to the more expensive Standard or Enterprise editions.
You did. Now, Web Edition customers can provision multi-AZ deployments, gaining synchronous data replication and automated failover without that significant cost uplift. It removes a major technical hurdle for achieving HA at a lower cost tier.
And finally, in migration, AWS DMS schema conversion added support for migrating from SAP ASE to RDS or Aurora PostgreSQL.
And it includes integrated generative AI. Migration from legacy proprietary systems like SAP ASE is notoriously difficult because of all the complex proprietary stored procedures, triggers, and functions.
And the GenAI helps with that conversion.
And handles those complex code conversions automatically. This significantly reduces the manual effort and the highly specialized engineering time required, which really accelerates the migration timeline to a modern PostgreSQL platform.
Our final segment covers the network edge, performance tuning, and how observability is getting an AI injection for troubleshooting.
Right, and ALB users receive two crucial operational features. First, health check logs.
This sounds like a tremendous troubleshooting aid. What specific data is included, and how is it delivered?
So ALB now delivers detailed target health check status and failure diagnostics to an S3 bucket every 5 minutes. The logs provide this granular visibility into why a specific target was marked unhealthy.
So you get the exact timestamp, the response code?
The response code and the specific failure reason like connection refused or timeout. This level of detail lets ops teams conduct root cause analysis far faster than just relying on console status updates alone. It's all about reducing that mean time to resolution.
And the second feature is the ALB Target Optimizer, which sounds like a very niche but powerful tool for fine-tuning application performance.
It is. It's aimed at compute-intensive applications like real-time ML inference models or complex image processing APIs where performance degrades rapidly under high concurrency.
So how does it work?
The Target Optimizer lets you enforce a maximum number of concurrent requests on a target via an AWS-provided agent that runs on that target.
So if my ML model can only handle 2 inference requests simultaneously without throttling, I can force the ALB to never send more than 2 requests to that specific target instance at a time.
Precise. This lets you fine-tune the application stack to operate at its optimal performance point. You get a higher request success rate, better target utilization, and lower latency by preventing the target from being overwhelmed.
And network architecture gained efficiency with API Gateway REST APIs, now supporting direct private integration with application load balancers.
Yes, this is a simplification of the networking stack. Previously, if you wanted API Gateway to talk privately to an internal ALB in a different VPC, you often had to introduce a network load balancer as an intermediate hop.
Which added latency and cost.
It did. By supporting direct Layer 7 private integration with the ALB, customers can eliminate that NLB, reducing latency, lowering infrastructure costs, and they can leverage the full suite of Layer 7 capabilities like path-based routing, directly.
Okay, we discussed governance, but flexible cost allocation is a massive piece of network governance.
It is. AWS Transit Gateway, or TGW, introduced flexible cost allocation, FCA.
And this is a fundamental change to shared network infrastructure chargeback, isn't it?
It is. TGW is a central service, and historically, data processing and transfer costs were always charged to the source account, sender pay. This often resulted in the central security or networking account just absorbing massive unallocated costs.
So how does FCA revolutionize that?
FCA lets you distribute the TGW costs across the source account, the destination account, or the central TGW owner account. And the metering policy is configured right at the attachment level or even the flow level.
So you can be really granular.
Very. And this immediately tied into AWS Network Firewall.
Right, update 59.
Yes. The synergy is immediate. Network Firewall often runs as a centralized service in a security VPC, inspecting all the traffic for every other application team. By leveraging FCA, the security team can automatically distribute those centralized firewall inspection costs based on usage to the specific application teams responsible for the traffic.
So you get accurate, automated, and fair chargeback.
Exactly. And for global networks, AWS Cloud WAN added routing policy for advanced traffic control.
So this is for really resilient global networks.
It is. You get features like route filtering, summarization, setting BGP attributes. This is vital for minimizing the blast radius of routing changes and preventing suboptimal or asymmetric connectivity paths.
At the edge, CloudFront functions receive some important enhancements.
3 of them, yeah.
Yeah.
They added access to edge location metadata, raw query string retrieval, and advanced origin overrides for customizing the SSL-TLS handshake.
Which of those is the most critical for architecture?
I'd say the advanced origin overrides are critical, specifically the ability to customize SNI or server name indication during the TLS handshake.
And why is that so important?
It's crucial for complex multi-tenant setups, where CloudFront is connecting to an origin that might use a different certificate domain name than the one the end user sees. It ensures successful TLS handshakes in those complex architectures that previously required some pretty ugly workarounds.
We also saw CloudFront announce support for CBOO web tokens and common access tokens for authentication at the edge.
Yes, CWT and COT. This is a performance optimization geared towards streaming and high-volume traffic. CWT uses concise binary object representation, or CBOR, which is a very compact binary data format.
So it's much smaller and more efficient to process than a standard JSON web token, a JWT.
Way more efficient at the scale of the CloudFront Edge network. It's about reducing payload size and processing time when you're validating millions of tokens per second for a big streaming platform.
Makes sense.
They also use CoOS for security. And CAT extends CWT with fine-grained access controls like IP restrictions. By doing this complex validation with efficient binary tokens right at the edge, you get sub-millisecond execution times without relying on slower origin lookups.
Got it. And finally, AWS Device Farm announced a fully managed Appium endpoint.
This just simplifies mobile and web testing. It allows developers to run interactive tests on physical devices directly from their IDE or local machine using standard tools like Appium Inspector. It streamlines debugging by providing live video and log streaming right to their local environment.
We have to end with how AI is accelerating operational response. Amazon ECS and EKS now have AI-powered troubleshooting directly in the console.
Yeah, via Amazon Q Developer, this is like a contextual help desk for your infrastructure.
So how does it work?
If a cluster operator sees a failed EKS control plane component or an unhealthy ECS task, they can click this new Inspect with Amazon Q button. Q then provides contextual analysis. It automatically gathers all the relevant logs, metrics, configuration details, and then analyzes the issue against known failure patterns and recommends mitigation actions.
So it dramatically accelerates root cause identification?
It really does. And that contextualization is being integrated right into the developer workflow. CloudWatch application signals launched a GitHub action.
Which brings observability directly into the CI/CD pipeline?
Exactly. Developers can enforce SLO breaching detection right inside their GitHub workflows. But the most significant piece is the improvement to the application signals MCP server. It allows AI coding agents like Kiro to identify the exact file, function, and line of code responsible for latency or error spikes.
So it connects the observability data directly to the source code repository.
It moves troubleshooting from these generalized "the service is slow" alerts to specific fixed line 42 of file X remediation instructions.
That is a massive reduction in the friction between ops and dev.
It connects those silos. And finally, just to round this out, CloudWatch application map received major enhancements. It can now detect and visualize uninstrumented services, provide cross-account unified views, and track change history.
And CloudWatch Database Insights now supports cross-account and cross-region monitoring.
Yes, giving DevOps teams that necessary centralized observability plane for their entire distributed database infrastructure.
So to summarize this immense 2-day release, we saw a clear acceleration in developer and data science workflows. That was driven by the convergence of Spark and Athena into SageMaker, the immediate utility of the AI data agent, and some major foundational security mandates.
Like the PQC adoption and the enforcement of encryption in transit.
Exactly.
So for technical teams, the mandate seems clear. Prioritize the opt-in security updates and really understand the governance shift. You have to explicitly review the documentation for those PQ-TLS security policies and start planning how to implement the require encryption in transit attribute in EC2 Fleet. And for cost management, that new Aurora DSQL cost visibility in the explain, analyze, verbose output is the most powerful tuning tool released in years.
We covered a huge amount of ground in security, data, and compute. The density of these updates requires immediate review, so, take a look at the specific documentation links for the new Lambda Kafka EPU sharing mechanism to realize those cost savings, and review the detailed configuration needed for the TGW flexible cost allocation if you run centralized networking services.
We discussed Update 73, the proactive compliance enforcement via required tagging in organizations' tag policies. That really marks a profound change in governance philosophy. It's moving from auditing failures after deployment to preventing non-compliance before deployment even completes using these ISE hooks.
It's a fundamental shift left.
It is, and it raises an important question for you, the listener, to explore. If security and compliance are enforced directly at the IAC stage in your CloudFormation, your Terraform, your Pulumi, what becomes the new role of traditional post-deployment auditing? And how does this immediate preventative feedback fundamentally change the relationship and the operational handover points between security architects and DevOps teams? Think about where that enforcement barrier officially sits now.